In example 9 of note 6.2, we are going to use trig identities and only trig identities to determine the other 5 trig ratios given one of the 6 trig ratios. So we're given that cotangent theta equals 3. We're also told that the angle is in the first quadrant. We're going to learn more about this in the next unit, but for now, if the angle's in the first quadrant, all the trig functions will be positive values. So if we ever have an option of a positive or negative value, we're going to choose the positive ones in this example. So we're given that cotangent theta equals 3. So I don't want to use a right triangle here, even though I could and do the like SOHCAHTOA type of analysis. I want to use trig identities. So if we're given cotangent theta equals 3, it's easy to find tangent theta because tangent theta is the reciprocal of cotangent theta. And we know that cotangent theta for this example is 3. So tangent theta is equal to 1/3. So we found one of the other trig ratios. Now we want to start continuing on and see if we can find other trig ratios. So we have to think about ways that these functions are related. So the next one, and you can stop the video and try to do some of these on your own and then come back. I'm just going to work through them step by step as I go, but you may want to stop and think about it a bit on your own. The next one, I can use a Pythagorean identity. And if I know tangent squared theta, I can get secant squared theta. So that identity is 1 plus tangent squared theta equals secant squared theta. This is the identity that we can remember with I tan in seconds. So using this identity, once we know tangent theta is 1/3, then we can say that 1 plus 1/3 squared is equal to secant squared theta. So this is 1 plus 1/9 is equal to secant squared theta. So that's 9/9 plus 1/9. So that is 10/9 equals secant squared theta. And now to isolate secant theta, we'll take the square root of both sides. And this is going to give us technically plus or minus rad 10 over 3. But we are going to take the positive root here because the angle's in the first quadrant. So take positive root, so secant theta is going to be the square root of 10 over 3 for our particular angle in the first quadrant. Now, once we know secant theta, we can use the reciprocal identity to determine cosine theta. So we know that cosine theta is the reciprocal of secant theta. So that means that cosine theta is going to be the reciprocal of rad 10 over 3. So that's going to be 3 over rad 10. And now we'll go ahead and rationalize the denominator. So rad 10 multiplying by rad 10 over rad 10 will be 3 rad 10 over 10 is the value for cosine theta. So now we have 3 of our 5 values that we need. Okay, next, once we know cosine theta, we can move on to sine theta using another Pythagorean identity. So the Pythagorean identity that relates sine theta and cosine theta is sine squared theta plus cosine squared theta is equal to 1. And we know what cosine theta is, so sine squared theta plus cosine theta is 3 root 10 over 10. And then we're going to square that. Or actually, rather than doing 3 root 10 over 10, let's use the unsimplified version, the one where we haven't rationalized the denominator. That will be easy. So it's 3 over rad 10 squared is equal to 1. So that means sine squared theta plus 9 over 10 is equal to 1. Isolating sine squared theta, we'll subtract 9/10 from both sides. So 1 minus 9/10 is 10/10 minus 9/10. So sine squared theta is 1/10. And now we will take the square root of both sides, giving us that sine theta is rad 1 over rad 10, which is 1 over rad 10. Go ahead, rationalize the denominator, multiplying by rad 10 over rad 10. So sine theta is rad 10 over 10. And I'm only taking the positive root here because we know this is in the first quadrant. So technically we would really have plus or minus here, but we're going to take the positive root. All right, we have one final angle to find, and that is cosecant theta. So once we know sine theta, we can determine cosecant theta because cosecant theta is the reciprocal of sine theta. And I'm going to go back to the version which is not rationalized, which is 1 over rad 10. So cosecant theta is going to be the reciprocal of 1 over rad 10, which is rad 10. Also note, you could have found cosecant theta. So as an alternative, you can find cosecant theta from cotangent theta using the Pythagorean identity. So you're using 1 I cotan and cosecant. So you can do 1 plus cotangent squared theta is equal to cosecant squared theta. So we know cotangent theta is 3. So you'd have 1 plus 3 squared is equal to cosecant squared theta. So 10 is equal to cosecant squared theta. And then take the square root of both sides. And we would get that cosecant theta is plus or minus rad 10, but we're going to take the positive root. So we get cosecant theta is rad 10. And then sine theta is the reciprocal of cosecant theta. So it's 1 over rad 10. Rationalizing that, we get rad 10 over 10. So two different approaches here. So this is second approach to find cosecant theta and sine theta.